Hi everyone. We are going to learn the most important part of MongoDB queries. I will explain three major concepts here: operators, filters, and sorting. These are heavily used in backend development and mainstack projects. And here how queries are working: filters, operators, and sorting working together fetch manage data effectively. We are going to what is query? A query is a way to retrieve or manipulate data from the database based on certain conditions in the main stack. And queries are mostly written using MongoDB plus Node.js on the backend. On the syntax here, db.collection and .find filter projection supports flexible JS1 based structure. The purpose of way used to query is to read and filter and update the data in specific data. Work similar to SQL queries but in NoSQL and MongoDB style. For example, we can ask it to give a as all the users are particularly only users above 18 years. And here how queries work in ManStack. We have to use in ManStack in front-end, back-end, database and responses. Here front-end we have to use React and back-end Node.js plus and Express and database MongoDB and response back-end sends the data back to front-end display. Whenever we click something like a filter or search on website, it sends a query to the backend which processes it and returns the correct data. And here we go filters. Filters helps to narrow down the result by applying specific conditions. The usage in the filter is used in backend Node.js plus Mongoose to get particular data from the MongoDB. And we can also be triggered by front-end inputs like search bars and drop-down filters, etc. And filters in the conditions we apply to a database to query to get only specific records instead of everything. In MongoDB, filters are written inside the file. And filters help us to get specific results instead of loading everything. For example, showing only products under 1000 rupees or user from the Hyderabad. And we go operators. Operators define how to compare values in queries. They are keywords prefixed with dollar symbol, and operators add power to queries used for comparisons and logics and array search, etc. Example: age dollar greater than 18 years. Here operators is equal to, greater than, less than matches any values in an array and combine conditions. Here some examples to operators. The real life example is student marks. I gave IDs and names in section math marks here. An example query. I'm asking select from the students where math greater than 80 ordered by the math desk in the table. And here I got the result. Ashay got the 95, who got the higher marks in section A in greater than 80, and second Kirti got 84. The result I got it. And sorting. Sorting is used to arrange data in ascending or descending order, sorted by prices, rating, name or date using e-commerce sites, low to high and high to low. And it organizes the data before it reaches front end, and this helps the users view data in a meaningful order. And the front end and back end roles we have to use in queries. Front end has we using React and backend Node.js plus Express and database in MongoDB. The rule we have to use in front end takes input from the users, filters and sort options, and backend Node.js plus Express builds query using filters and operator sorting. And here the last one, database MongoDB execute query and sends result. And here the examples. And finally is the summary. Queries helps to fetch data efficiently, and filters refine the results based on conditions, and operators defines the logic greater than, less than, equal to and etc. And the sorting organizes the data assigning, designing used to mainly in backend but triggered via frontend. And the real world uses the cases is e-commerce. Filters are products by prices and category brands. And the social media has sort posters by latest are most liked. And the admin dashboard filters used by role and status. Here, coming to the code, we create app.js server. And here, first two lines, we are importing the Express module and creating an Express application. Then Express helps us easily build a backend server using Node.js. Line 3 app.use express.js1. This line allows our app to handle JS1 data in requests, and it helps us send and receive data between frontend and backend JS1 format. And here 6 to 11 we create a in-memory queue, basically an array that stores our task data. Each task can ID, a name, a priority, and a status pending or completed. And line 13 and 14, this sets up a get route for the route path. When someone opens our app in a browser, this route runs and sends back in the HTML page. And 15 to 33, this part is the front-end interface. It includes a title, queue demo, and another dropdown as sort task by priority, and a dropdown to filter task by status. It has been pending or completed, and we give a button to apply. The application has been run it, and slash fuel to display queue items dynamically. And 35 to 37, this function runs when we click the apply button. It gets the selected filter and sorting options from the dropdowns. And line 38, const data equal to await result.js1. This line calls backend API queue and sends the select status and sort options to query parameters, and the backend will return the filter and sorted task. In the remaining lines, once data is fetched, JavaScript dynamically update the UL eliminate to show the filter queue task on screen. And the summary is, this code combines both backend and frontend in a single file using Express. It creates a mini web server that serves from a simple in-memory queue and display it with filtering and sorting options. This demonstrates how backend logic connects with front-end and interactivity. And the overview is, this project is a simple queue management demo built using Node.js and Express.js. The main goal of this code is to show the backend and frontend can work together in a single file. The backend is built with Express.js, which helps to create a web server easily. And the project uses an in-memory array called queue that stores a few tasks. Each task has four properties, has ID, name, priority, and status. The frontend is served directly from the same Express app. It includes a simple HTML page with drop-down menus to filter tasks by status and sorted them by priority. When the user clicks apply button, the function sends fetch requests to the backend to get filtered data. The backend processes this request and returns the queue data, which is then displayed dynamically on the web page.